Alrighty, looks like there's going to be a hard one today. Continuation of yesterday's part 1. I think I have like an hour in me. Alright, let's see it. Divide an array into subarrays with minimum cost part 2. You are given 0 index integer array nums of length n, 2 integers k and distance. The cost of an array is the value of its first element. Okay, same as yesterday. So 1, 2, 3, the first element that is 1, so the cost of it is 1, 3, 4, 1. First element is 3, so the cost is 3. You need to divide the nums into k disjoint contiguous subarrays. Okay, so split it up into multiple subarrays such that the difference between the starting index of the second subarray and the starting index of the kth subarray must be less than or equal to distance. The difference between the starting index of the second subarray and the starting index of the kth subarray. Interesting. In other words, if you divide nums into subarrays, nums from 0 to I minus 1, nums from nums from 0 to I sub 1 minus 1, nums from I sub 1 to I minus 2 sub, so I and then the sub number is just the identifier. Then so the difference, yeah, so indices can only be at most distance away from the second subarray index of the first element of the second subarray. Return the minimum possible sum of the cost of these subarrays. So distance is 3 partitions, so like the third subarray needs to be at most 3 away from the second subarray. The first element of the third subarray must be at most 3 away from this. So I'm guessing it's 2, 2, and 1. Okay, yeah, that's still, that would still be the same if the distance was more. So k is 3, distance is 3, so if you have 1 here, then you can't have this 1. 3 away from it is this 2, so it'd be 10, 2, 2, and 1. Okay. Here the distance is 1 away, so it's either 8 and 10, or 8 and 18, or 18 and 9. So you prefer the 8 and 18. So it's 10, 8, 18. This is a kind of weird formulation of a problem. So the first element is arbitrary. So you can kind of ignore it and think of it as how to do the remaining k minus 1 subarrays such that they're a certain distance away from the starting point, where the starting point can be pretty much anything after the first element. Okay. Alright, let's go ahead and just look at, alright, it's 10 to the 5th number of values in this array. So it's unlikely to be an n squared algorithm, time complexity wise. Probably some form of n log n, I want to say. So dynamic programming is generally n squared, so it's probably not dynamic programming. Might be some sort of heap. Might be some sort of binary search. Can I do binary search? I feel like this should be binary searchable. I do binary search. If it's a binary search, it's not going to be a usual one because normal binary search type algorithms would require creating some sort of function that validates the array in to see if it passes a certain threshold or is lower than a certain threshold in O of n time. So if there's a function that sees if it's possible to get a certain output, let's say that certain output is 10 for this array with these kind of parameters, and it has to do it in a single pass to determine that yes/no question, and then it kind of modifies you modify this using binary search. But I don't, off the top of my head, I don't immediately recognize a way to, if you're given a certain minimum, to verify if that minimum is possible in O of n time on the array. Like if you say, is 5 possible? How would you how would you do that? Is 5 possible? So heap seems, so if I think of this in terms of heap, the heap, you're keeping the two lowest elements that are at most 3 away. How would you modify that heap as you iterate through the indices? You're keeping the 3 lowest that are most 3 away from the first one. So it'd be like 1, 2, 2, I guess, or 2, 2, 1. Keeping the two lowest that's 1 away from each other. 2 lowest that are 1 away, so you keep track of a heap. Nasty. Hmm. Hmm. If you have a heap where the heap is tuples with the lowest value comma index, so it sorts by low value and then by index, and then you keep track of indices somehow. I think that might work actually. Tuples of value and index for that value. For every, so let's go ahead and start off the heap. Start off the heap should be, it should be k minus 1 elements in the heap after starting with index 1 rather than index 0. So maybe I should actually just use a list comprehension here. I can use list comprehension, or I can use a for loop. I'll use list comprehension here to initialize the heap. Heap is, let's say, value and index for every index in range from 1 to k, I want to say. So if it k is 4, then I want to go 3 elements in the heap. And then in the for loop, I'll add in the final element to the heap and then process it. So k is 4, so it goes from 1, 2, 3, so that's 3 elements. And index value is actually, value is nums at index. Okay, and let's go and just print out the heap, make sure that this is doing that correctly. So k is 2, so I want 3, 1, 2, 2. 4, I want 1, 1, 2, 2, 2, 3. Okay. And then once you use this comprehension to initialize the values of the heap, you do need to use heapify to actually kind of sort up the heap and make it in the correct order with the front of the heap is the smallest value. And then I also need to still find the sum of these values. I need to find the sum of these values. How do I find the sum of these values? I guess I just need to actually use a for loop to do this. Heap.append nums at index, and answer plus equals. No, I need to keep a partial. Answer is the minimum. I need to keep track of just the total. And then I need to do heapify. Okay, so now it's the key part here, and that's for each iteration k to n, where n is the number of elements in the array. I need to consider adding the value index onto the heap and then modifying the total somehow. Total. No, fuck. I'm not doing this right. Oh boy. It's not k. No, maybe this is right. Yeah, I think. Is this right? Yeah, I think this is right. Actually, this is. Alright, so I have values nums at this index. I need to add this to the heap. Heap push value and this index onto the heap. Push is 2 parameters, the heap variable and the value or the data to push onto the heap. And then that should modify the total. And then I need to remove the heap needs to maintain its size. The heap needs to maintain its size. And also the heap needs to yeah. Oh boy. Okay. Yeah, I'm now realizing how I'm screwing this up. So for instance, if it's pushing four values onto the heap, no, 3 values onto the heap here. So it needs to maintain 3 pushes, so this is 3. Then I'll pop this thing off. Next iteration, this is 3. And this is not really, these examples aren't great. So if, let's say nums is 1, let's say something like 5, 2, 1, 3, 2, 3, 3, 5. What am I thinking of here? Say k is 3. And distance is 3. So the answer here would be 2 and 3. So I'm thinking somehow if you remove something from the heap that is a low value because it's out of range, you might need to put back onto heap something that is within range that is also low. So like, let's say this was something like this. One. So 1, 2, 1. At some point the heap is going to just be 1, 1, 1. And the 2 is popped off because 1, 1, 1 is smaller. But then when you get to, so it's like this thing is right, that's the heap, or that's the kind of thing in consideration from k being, or the index being here, stretching back 3. If the heap is just the bottommost 3 values, it's 1, 1, 1. But then when it extends so that this is the values in consideration, it needs to push back on this 2, back onto the heap, because that's part of the smallest 3. Interesting. So I think it needs to have like 2 heaps almost, like the smallest within this current range, the smallest k in the current range, or the smallest, yeah, the smallest k in the current range, smallest k, smallest k in the current range, k minus 1 in the current range. Answer should initially start with nums at 0. Small, the heap needs to have k minus 1 elements. Yeah. there needs to be a secondary heap. That's kind of your discarded heap, or maybe not discarded, but in range but not currently used. I'll say active and inactive heap. Yeah, I'll say active heap is this. This will have heap of tuples to track lowest k-1 values in range of current index. And then I'll have an inactive heap, which is heap of other tuples to track kind of non-lowest k-1 value, non-lowest values in range, because you need both. Okay, so active good old heaps. So at this point there's nothing inactive. And I need to store the small. Min total. I guess this should probably be min total right here. Min total is k minus. Min total is initially whatever this sum of the values in this heap is. Okay, heapify the active heap. Okay, so this is the latest index is the current index. I need to, what do I need to do? I need to add that onto the heap. And then I need to maintain I need to reconfigure the heap so that it's in range. I need to make the heap smaller. Make the heap smaller. So right now the heap's too big. So it's currently, the heap is going to be k size here. The heap is going to be k size, so I need to make it k-1 size, so I need to pop guard this. It could also be the heap could also be could be wrong. Right. Index could be wrong. How do I track the indices in the heap? How to track indices. Sorting by just the smallest. It doesn't, it's going to keep down. It might not remove this. The front of the heap might not have the earliest kind of value that's still correct. Do I need to have another heap? Or do I need to have some sort of tracker? Or the indices? One, two, two, one. Minimum possible sum the cost of these subarrays. If I start off with a certain spot, I'm basically finding the smallest values within a certain distance after. So 3, and then the two smallest ones after the 3, that's within distance of 3. Or if I have 4, then starting with 1 within distance of 3. Some sort of sliding window? Sliding window with a heap? Window should always have a distance. The window should always have what if I do a sliding window? That works. Yeah. Here's too big here. If I do sliding window, I still need to maintain some sort of heap for the window. The heap needs to somehow keep track of things. Keep track of things that are within the window, somewhere buried along in the heap. So what's the example that I can use here? I think it's something like maybe hmm. Oh god. Actually, now that I think about it, I think my heap needs to be max sorted because I want to find the largest of the values to remove from the heap, rather than min sorted, because min always will probably be part of the heap, part of the k that I want to keep. Oh boy, oh boy, oh boy. Lowest k minus 1 values. So logically, the heap needs to track k minus 1 values in order to keep track of the lowest ones. I mean, there's just no other way to use a heap, right? You need to track the lowest k minus 1 values that you want to actually add up to form your values to be the front of your subarrays. Dividing the array into 3 parts. One part is definitely including the front one. The other 2 parts are somewhere behind that. So you need to keep track of 2 things, where the distance between the very first of those 2 things and the last of those 2 things is 3 away. Here it's 4 divisions. First division is always the 10. Other 3 divisions needs to be within 3 away of the first and the lowest 3. So it has to be the lowest 3. So the top heap that you're concerned about is always k minus 1 sized. Or it should be k minus 1 sized. And then there should be another heap that kind of is working with it. There should be another heap that's working within it. Working with it because in order to maintain this distance constraint, if you add an element to the heap, at a certain index, the front of the heap needs to remove anything that's out of range. But then you need to add back into it, into the heap, anything that was discarded that is in range that is smaller than the newly added element. So let's say it's infinity here. And it was like 1 something like that. So 111 is, let's say this is 4. So 111 is the heap here. I guess this should be 4 if I consider the 3 lowest. So 111 is the bottommost 3 here, and then I guess this distance should be 3. And then when you consider this index, we remove this 1 because it's out of range of this 3. But then you don't want to keep 113 because 2 is actually better. So you push back into 2. But how do you know how to get rid of this 1? So is there some sort of how do you know get rid of that 1? Unless you had 2 heaps, one is based on the index and the other one's based on the value. If you have a heap that has the bottommost 3 values, and something's out of range, then you need to remove that answer from the total for the heap. You remove that answer from the total of the heap. And then you need to add in stuff. You add in stuff. Alright, I think it's time for bed. This one I feel like I'm actually kind of close on, even though I haven't even coded very much.